A zero energy building is a building with net zero energy consumption, meaning the total amount of energy used by the building on an annual basis is equal to the amount of renewable energy created on the site. The goal is that these buildings contribute less overall greenhouse gas to the atmosphere during operation than similar non-zero energy buildings. Some of the advantages of these zero energy buildings are high resale value, increased comfort in living, better reliability, economical even in the long run, environmental capability, low emission of carbon, sustainable construction, reduction in the net monthly expense of living. Other benefits you get from a zero energy building are tax incentives, home orientation, superior insulative quality, and energy building, minimizing your ecology footprint, comfort in your living space, both in the interiors and even some parts of the exteriors, like your seat house and all, and also its budget flexibility. The most cost-effective step towards a reduction in the building energy consumption usually occurs during the design process. In passive solar building designs, windows, walls, floors are made to collect or store, also to reflect and distribute solar energy in the form of heat in the winter and reject solar heat in summer. This is called the passive solar design. Unlike the active solar heating system, it does not involve the use of mechanical and electrical devices. The key to designing a passive solar building is to best take the advantage of the local climate, performing an accurate site analysis. Elements to be considered include the window placement and sizes, and glass to be used on those windows, and if there are going to be glass doors, thermal insulation, thermal mass, and shading. Passive solar design technique can be applied most easily to new buildings, but existing building can just be adapted or maybe renovated. Use sunlight without active mechanical system. Such technology converts sunlight into usable heat, plus air movement for ventilating or future use, with little use of the other energy sources. The ability to achieve this goal is to fundamentally depend on the seasonal variation in the sun path throughout the day. This occurs as a result of inclination on the Earth's axis, rotation, and relation to its orbit. Site analysis acts as a gateway to conscious design and environmental responsive architecture. Is a gateway to a conscious design and environmental responsive architecture. It is a pre-design research activity which focuses on existing and potential conditions on and around the building site. Nigeria. Nigeria is a country in the West Africa. Nigeria shares border with the Republic of Benin in the west, Chad and Cameroon in the east, and Niger in the north. Its coast lies on the Gulf of Guinea and on the south. The geography of Nigeria is a combination of the distinctive regions, including deserts, swamps, plains, mountains, and forests. Nigeria covers 356,667 square miles, making it the 31st largest country in the world. The climate in Nigeria is evident from temperature increase, rainfall variability, droughts, desertation, rising sea level, erosion, flood, thunderstorm, bushfire, landslides, radiation, and loss of biodiversity. Nigeria has its highest temperature of about 36 degrees Celsius during the Harmattan, popularly known as dry season, from November to March. During the rainy season, April to October, the temperature drops to a maximum of 24 degrees Celsius. Site location. The site is located at Karua with code number 900103, Abuja, Nigeria, along the highway right turn before the city gates. The site is 22,000 square meters. The Abuja City Gate is a monument which is located in the city center of the capital, Federal Republic of Nigeria, Abuja. Climate of Abuja. Abuja, the Federal Republic of Nigeria, is one of the coldest regions in Nigeria with an average daily high temperature of 30 degrees. With a yearly average of 32 degrees, the climate is very warm, but has only a few tropical and humid months. The sun rises from the east at about 6:30 a.m. and it sets on the west at about 6:30 p.m. Chemicals are most likely to be used to remove some of the dissertations in the sites, such as the tire material. The type of soil found on the sites is laterite, mostly grey, black, and sand. They are floody and sticky, not well diluted by water, and has low fertility. One advantage of this soil is that it could be used for making bricks. The type of trees found on the site are trees that could be used for beautification and landscaping, though some of the site's trees are going to be removed. The southwest wind comes from the Atlantic Ocean and it is usually moist and cold. The northeast wind comes from the Sahara Desert and it's usually dry and harsh. The greatest noise comes into the site from the south due to the highway and node present very close to the site. Proper setback should be observed from the overhanging high-tension cables. The compass on site faces the major node, which tilts the site at an angle of 45 degrees. Setback standard in Abuja, Nigeria. In Abuja, the setbacks are 6 meters from the approach to the property line, 4.5 meters from the rear to the property line, and then 3 meters on both sides, left and right side. The building on the west contains the cinema, adaptive performance hall, the restaurant, the technical service, and workshop spaces. The ground floor is made open to have open performances and to allow the direct airflow vertically and horizontally. On the first floor are 3 performance halls, waiting rooms, conveniences, and terraces all around with workshop space. On the second floor is the presence of 3 cinemas. The slope braking system in the cinema helps to achieve a waiting room, and also on the second floor we have the technical space, and on the third floor is the continuous braking system of the cinemas, waiting rooms, and restaurants. The open spaces and the use of void helps to have a consistent flow of air. The use of vertical shading devices on the west and the east side helps to shade off the direct sunlight from the east and west. The materials used for this building are wood, adobe bricks, concrete, and the use of a popular material in Nigeria called the bamboo. The bamboos are gotten in Nigeria naturally. The weaving is an ancient pattern used by the Hausas of Nigeria. It has been used here to have a vernacular feel to link up buildings. Getting to the next building, which entails the admin and the shopping mall. Encompassing a trail ramp from the ground floor to the first floor, where we have the shopping and all. Antrim has been used as one of the passive cooling techniques also. The presence of a wind catcher and a slopy pallet, which helps to increase the pressure of the wind that gets into the building on the strata call of the building. Vertical shading devices on the left and the right side of the building has been used. Now getting to the next structure is an elevated parking space of 50 capacity. Going on the pathway lead us to the residential part of the site, which is situated by the northern part of the site. Double facade has been used also as one of the possibilities. Vertical shading devices have also been used in the residential buildings and an open space in form of a courtyard. Wind catchers in form of wide and short windows have been used over the building close to the roof as one of the passive techniques.